Dear students, in this section, we will see a numerical problem on solving the pump by using the similarity method, that is a similitude method. So let us go with the problem. A 1/5 model of a pump was tested in a laboratory at 1000 rpm. So when you are going to make the real prototype, it will incur more cost. So before making the real prototype, we will make some scaled down model. Generally, it will be scaled down model. In some application, it can be also scaled up model. But in this particular problem, it's a scaled down model. We are not going to make the real prototype, but we are going to make the model, which is of 1/5 model. And this model is going to be tested at the laboratory at a speed of 1000 rpm. The head developed by this model is 8 meter and the input power required for this pump is 30 kilowatts. So these are the data given for the model. So let us have for the model, the speed is 1000 rpm. The head developed H1 is 8 meters. The input power required for driving this pump is 30 kilowatts. Now I want to make the real prototype. So let us come to the real prototype. It has to work against a head of 25 meters. So this actual head should be what? Not 8 meters. It should be able to pump the water up to a height of 25 meters. Determine its working speed. So they're asking what is the N2 or NP. NP means prototype. N2 also prototype only. The power required. So what is P2? So what is the power required for running this prototype? And the ratio of the flow rates handled by the two pumps. Either it can be Q2 by Q1 or Q1 by Q2. So these are the questions asked in the problem. I will repeat once again. This problem is especially useful when you want to develop a model instead of making a real prototype. The real prototype is bigger in size and his head to be developed is 25 meters. Whereas the 1/5 model, what is meant by 1/5 model? Which means D1 is equal to 1 by 5 of D2. Because D2 will be bigger. You know that. So D2 will be what? Bigger. So D1 will be 1/5 of the D2. That is also one of the data given. Based on this, what do we want to find? We want to find the speed of the prototype. We want to find the power required for the prototype and the ratio of this flow rates. Okay. In continuing further, if you know the formula directly, we can substitute. But let us derive it within 2 minutes. It will not take much time. So we know the characteristics of a pump or the outcome of the pumps are Q and H. We want enough flow rate as well as we want enough head. As well as we know that phi, which is nothing but a speed ratio, which is nothing but U by V, where U is the speed of the blades. There are two velocities in a pump. One is the velocity of the blade and another is the velocity of the fluid. So use the velocity of the blades, which is given by pi dn by 60, and V is given by a formula called what? 2gh. If the head is more, then the velocity will also be more. So V equal to, this is the fluid velocity, this is the solid velocity or the blade velocity. So I can write phi is directly proportional to dn by square root of h. So you may ask what happened to this pi, 60, 2g and all, they are constants. So I remove the constant and put a proportionality. So phi is directly proportional to dn by square root of h. What about phi? Phi is also a constant. Y is a constant, u is also a constant, v is also a constant. So phi is also a constant, which means dn by root of h is equal to constant, which means d1 n1 by square root of h1 is equal to what? d2 n2 by square root of h2. Whether you know d1 d2, yes, I know the ratio of d1 by d2 will be equal to what? 1 by 5. So I know the value of d1 by d2. What about n1? Yes, I know. What about h1? I know. What about h2? I know. What is the only unknown from this equation? N2. So we can find is the N2. So one equation, one variable is very easy to find the answer. So by using this formula, d1 by d2 will be what? 1 by 5. What about n1? n1 is 1000. Already we have brought this d2 here. So only unknown is n2 here. By what is square root of h1? Square root of 8. This side, what is the square root of h2? That is what we, square root of h2 is also given. h2 is 25. So the only unknown is what? N2. So we can find the value of N2 easily. So we can find the value of N2 easily by this formula. 353.5 RPM. So we can see that we are able to easily calculate the value of N2. What is meant by N2? The speed of the prototype will be what? 353.5 RPM. So it's going to rotate at a speed lesser than the speed of the model. So it's going to rotate at 353.5 RPM. Now what are the other questions you asked? This is solved. So we want to find P2. We want to find P2. Okay, fine. I will erase the top one so that we can make use of the data which is provided in the bottom. So we see the hydraulic power of a pump will be given by rho g q h. Okay, the hydraulic power will be given by rho g q h. From this, rho and g are constant because the density of the water is constant, g is constant, q and h are variable. So the power required for the pump directly depends upon q and h. We know that q is a function of a and v, area and velocity. Area is a function of pi by 4 d squared and v is a function of square root of 2gh. And h is a function of h. So we have to take all these three terms. So from this term we can omit pi by 4, so it becomes d squared. From this term we can omit square root of 2g, so it will become root h. From this term it is h. So what I can tell from this is that the power required for the pump is proportional to d squared into square root of h into h. So power is directly to d squared h power half into h power 1, which means power is directly proportional to d squared into h power 3 by 2. Okay, h power 3 by 2. Now, what does it means? P by d squared h power 3 by 2 is constant. What does it means? P1 by d1 squared h1 power 3 by 2 is equal to P2 by d2 squared h2 power 3 by 2. Now you see, P1 is known, P1 is given. So you can substitute the value of P1 in kilowatt itself directly. D1 by D2 is known because D1 by D2 is known. So these two things are known. H1 is given. H2 is also given. So the only unknown is what? P2. So we can find the value of P2 very easily. So it's a very easy method. So how I proceeded, I will make it fast. The power of the hydraulic power of the pump will be equal to rho g qh. Rho and g are constant. So P is power is directly depends upon Q and H. Q equal to area into velocity. Area is once again a function of d squared. Velocity is a function of square root of h. Already this h is also there. So this h. So now power becomes d squared whole power h by 3 by 2. From this what we are getting? This expression. From this expression which is unknown, P2 is only unknown. So we can get the value of P2 directly. So I will write it here. What is P1? 30 kilowatts. How can I write this one? D1 by dt whole squared, which means 1 by 5 the whole squared. What is H1? H1 is 8 power 3 by 2 will be equal to P2. What is P2? P2 is unknown. We have to find it out. D2 is already taken to this side. What is H2? 25 whole power 3 by 2. So from this we can find out the value of the power required for running the prototype. Prototype is the real product what we want to develop. By substituting in this formula, this value, we are getting the value of P2 to be 4143 kilowatts. Okay, so it's a very simple problem. We have to just derive some expressions and non-dimensional expressions. From that we will be able to get the values of the unknowns from the given problem. So we found the value of P2. Now what is the next step? We have to find either Q2 by Q1 or Q1 by Q2. Is nothing but the ratio of the flow rates. So now we have to include some terms which include Q. So here we have include some terms which includes power. In the first one we include some terms which include speed. Got the logic? So we have just applied the formula which is required for what you want to find it out. Okay, I hope you got it. Now proceeding like this, now I want to include some terms which is having Q. Then only I can find the ratio of Q2 by Q1, isn't it? So we can say that Q equal to A into V, as well as Q will be, this will be pi by 4 squared, this V will be square root of 2GH. So I can tell Q is direct proportional to D squared into square root of H, which means Q by D squared into square root of H is equal to constant, which means Q1 by D1 squared square root of H1 is equal to Q2 divided by D2 squared of root of H2. So whether you know D1 by D2, yes, D1 by D2 is equal to 1 by 5. So I can find D1 by D2 whole squared. H1 is given, H2 is given. They have not given Q1 or Q2. So that they are asking the ratio of Q2 by Q1 or Q1 by Q2. So I hope I can erase these values. So we can see here, I will find out the value of Q2 by Q1. Q2 by Q1 will be equal to, Q2 by Q1 will be equal to D2 by D1 the whole square into square root of H2 by square root of H1. What is D2 by D1? D1 by D2 is 1 by 5. So D2 by D1 will be equal to 5. So 5 whole square into square root of, I hope head is 25 meters for the prototype, and for the model it is 8. So from this we can find the value of Q2 by Q1. So this value, from this we can be able to get the ratio of Q2 by Q1. This value of Q2 by Q1 is coming to be around 44.1875. So it's a very simple problem where we'll be able to find the solutions whatever we require by doing a similarity analysis or a similitude analysis. I hope you enjoyed the numerical part of this problem. Hope to see more problems. Thank you.